Hello and welcome to Quick Maths Revision, where today we're going to be going through a guide on GCSE 91 on surds. So in this video we'll be going over how to simplify surds, what is a surd, multiplying, dividing, adding and subtracting surds. I'll put up a separate video on rationalising the denominator, so check that out if that's what you're looking for specifically. So before we can talk about what a surd is, it makes sense to first talk about what a square root is, as surds work with square roots. So if we have a number, it is a square number if it can be written as the product of one number multiplied by itself, which sounds more complicated than it is. So 16 is a square number because it can be written as 4 times 4, which is 4 squared. So 16 is the square number and 4 is the square root of 16. So the opposite of squaring a number is to square root it. So if we have 25, which is a square number, if we were to square root it, we find the number which when multiplied by itself gives us 25, which is 5. So 5 is the square root of 25. Okay, so now that we know what a square root is, we can now look at what a surd is. So a surd is a square root of a number which can't be written as a whole integer value, so 5, 6, 7 example. So what we have to do is we can simplify them down to its simplest form, but we'll never get rid of this square root symbol. So before we can work with surds, we need to learn the key rule when it comes to simplifying surds, which is that if we have a square root of a times b, where a and b are any two numbers, we can write that as the square root of a multiplied by the square root of b. So it might look a bit confusing, but all we do is we can replace a and b with any two numbers we want. So the square root of 10 times the square root of 6 is the square root of 10 times the square root of 6. And you can do that with any positive numbers a or b. So now that we know what this rule is, so this one's the main rule when it comes to simplifying surds, we can use this to simplify our surds. So if we had a question in an exam which was simplify the square root of 8, what we'd have to do is we'd have to split 8 up into two numbers which when multiplied together give us 8, which we'll use then our rule from before. So 8 is 4 times 2, and then using this rule which is in red, we're going to split that into two separate surds. And we already know that the square root of 4 is 2. So then what we're left is this. And then what we can do is we can write that in a simpler form, which is where we have just 2 root 2. Nice and easy. So what we now know is that root 8 here is the same as 2 root 2. So we've just written this in a different form. And this is the most simplified form of a surd. Another question we might have would be write root 27 in its simplest form. So the trick with simplifying surds is you always want one of the numbers that you're separating your bigger number into to be a square number. So in this example before we had 4 and 2. So 4 was the square number in this case. So with 27 what we're going to do is similar to that. 27 is 9 times by 3, and 9 is our square number, so when we do this step here, following our rule from before, we can write this as 3, which makes things a bit easier, and we can then write it in our nice form, which is just 3 root 3, and that's our answer. Okay, so our rule from before works both ways. So in these examples here, we've used it where we have one number and then we've written it as a product of 2 under one square root and then split it into two surds. We can do it the other way around. So if we had two surds and then we were multiplying them together, so root 3 times by root 2, we'd do the opposite. So what we do is then we can say that this is the same as root 3 times root 2, all under one square root. So as you can see, we're doing this, but going from right to left rather than left to right this time. So we've got two numbers and then making it into one combined one. And then we can just do simple multiplication to give us root 6. So that's quite straightforward. Things get a bit more difficult if you have numbers as well, so whole numbers as well as your square roots. So if you had 2 root 6 times by 3 root 3, for example, what we have to do is we have to multiply the numbers on the outside and then the surds separately. So what we'd have is we'd have 2 times 3, so that's our whole numbers, and then we'd have the square root of 6 times by the square root of 3. So 2 times 3 is 6, and then here we'll have the square root of 18. So we could leave it like that, or we could simplify it further. So using what we did before, we'd have 6, and then we'd have the square root, and then 18 is 9 times 2. So then following through from before, we can write that as 2 different surds, and then we know that root 9 is 3, and then we know that 6 times 3 is 18. So the answer is 18 root 2. So that's how you multiply surds. Dividing surds, it's quite straightforward. You just put them like a fraction like you would normally. There are a couple of examples which are a bit different. So if you had this, for example, the answer to this is 1. So it's similar to if you had 3 over 3 or 2 over 2. So just because the top and the bottom are the same, they divide through and you just get 1. Another more interesting one, if you have a number and then you divide by the square root of that number, your answer is the square root of that number. So if you're not too sure why that works, if you multiply both sides by root 7, you'll see we get 7 over root 7 times root 7 equals root 7 times root 7. And then what happens is these two cancel, and you just get 7 is root 7 times root 7. So you can see that this works. And if you had, for example, 2 different surds, like so, you could just simply write it as root 3 over root 2. So that's dividing surds. And now if we go on to adding or subtracting, it makes more sense to look at them like algebra rather than surds. So if you had 7a plus 6a, because they're both in terms of a, you just add them up and you'd get 13a. And if you swap a's with surds, for example, then you can do the same. So you do 7 plus 6, 13 root 2. And if you had, for example, 6a plus 2b, we know that we can't simplify that any further. So if you had 6 root 2 plus 2 root 3, we can't simplify that further either. And this logic works exactly the same for subtraction. So I'll just give a more interesting example. So if you had 3 root 3 minus root 3, this is the same as 3 root 3 minus 1 root 3, which if you then thought of that as 3a minus a, you'd get 2a, which means that our answer is then 2 root 3. So what I'll do is I'll leave that there, and that covers all the basics of surds. So that's everything you could need to know about surds in basic questions that might come up. What I'll do is I'll follow this up with a further video on rationalising the denominator, which is a more complicated skill that you might need when working with surds in exams. So be sure to check that out if that's what you're looking for, and hope you found this useful.